Assalamualaikum, my name is Ahmad and I am going to demonstrate how to translate the selection statement in a compiler. In this slide, we have a code written in C language that calculates the minimum of two numbers. We take inputs x and input y, and then there is a conditional statement if that will check whether the x is smaller than y, then the minimum is x, otherwise the minimum is y, and then it finally prints the minimum number. Here we have the three address code of the previous C program, and we can see there is a selection statement at the line number 3. So this is a grammar for an if-else statement. We can see the statement can be an if, and there is a branch equals instruction that is enclosed inside the bracket, and the branch equals instruction can be an ID and relational operator and then another ID. And the statement can also be an assignment operation. The problem faced in this scenario is that what instruction that go to instruction should jump into, because up till this point the jump instructions are not known to the compiler. So the further instruction has to be compiled, it has to be scanned to get those instructions. So the solution for this problem is to leave the address field of those instructions blank and move on to the next instructions. And when we are clear enough that what instructions has to be placed on that address field, then we come back to those instructions and backpatch the addresses of those functions, of those instructions. So we need to save the line numbers of the instructions that needs to be backpatched. Here in this slide, there is a simple backpatch function that takes in two arguments, a line number and a value, and it appends the value to the end of the line number that has been given to the backpatch function. To keep the track of the line numbers, we take the help of a global variable named n, which has been initialized with 1, and after every emit statement, this global variable n is incremented. Here in this slide, we have a grammar with actions. So let's take a look at this line by line. First, we have a global variable n, which has been initialized to 1. Next, we have an if statement, and there is a branch equals instruction enclosed inside the bracket. And after that, there is a backbatch function. Now, at this point, we know that this is the line where the goto instruction has to take us to, because this is the condition. This is where the condition is true. So after the true condition, the goto instruction has to take us to this line. So we know at this point, and then we are backpatching over here. And after that, there is a next statement to avoid else if the if statement is being true, and after that there is an else statement for the branch equals dot f, which corresponds for branch which false if condition statement, and here we are also backpatching for the false statement, and finally after the s2 we are backpatching for s dot next. At the branch equals in statement, we have an ID1 relational operator and then an ID2. So at this point, we don't have any information about where the branch instruction has to take us to. So we just write an initial structure if ID number 1 dot lex and relational operator, and then ID number 2 dot lex, and then go to. And you can see that after go to, there is no number that has been written, and those numbers will be backpatched later on. And similarly, after that, we have also the go to for branch false statement also, and we have saved the line numbers of them at be.t and be.f. In the further slides, we're going to try run the program that we're doing. Here in this slide, there is a high-level parse tree that is of our previous program, and we can see that the first statement that is going to run is the instruction that will take input from the user and store it on variable x. The next instruction is to take the user input on variable y. So this slide shows the output that has been generated up till now, and you can see there is 3 underscore for input that we've taken x and input y, and the global variable has been incremented 2 times since there are 2 emit statements that has been done up to now. Here in this slide, there is a in-depth subtree of the previous parse tree, and we can see there are actions that are being annotated in this subtree. A5 is the first action that will execute, and it will have two emit statements, and that will result in the global variable to increment two times, and the global variable n will increment up to 5, and the two emit statements that are written at the bottom right corner of this slide, which is if x is less than equals to y, go to, and number 4 statement is just a simple go to, and which will be backpatched in the later slides. The next action that will execute is A1. This action will backpatch the third statement, which is the true case of the if condition. So it will send the pe.t, which is the line number that needs to be backpatched, and n, which is the line number where which is a value which has to be placed at the third line number. The next action that will execute is a dollar sign, which is simple an assignment operation, and it will emit that min equals to x and increment the global variable n to 6. The next action that will be executed is a2. In this action, the s.next variable is saved the value and which is current line number, and then it will emit the go-to statement. This go-to statement is there to make sure that after the successful entry inside the if statement, then the program must not enter the else statement, it must jump away from the else statement. So this go-to will be backpatched later, and finally the global variable n has been incremented to 7 after the emit statement. The next section that will execute is A3. In this section, the backpatch function will be triggered, and this backpatch function will be sending the parameter pe.f, which means that this backpatch function is for the case when the if statement is false. So it will backpatch the fourth line number and append the value 7, which is the current line number global variable. Here we have not incremented any global variable since there is no image statement that has been done here. So the next section is the a dollar sign action, which is simple an assignment operation. The min equals to y will be emitted, and the global variable n will be incremented to 8. Finally, there is action A4, in which the backpatching of s.next will be done. Backpatch will be given the parameters s.next, which is the line at which the backpatching will be done, and the parameter n, which is the current line number. So at line number 6, after the go-to statement, the number 8 will be appended. So after all the backpatching and if-else statements emission, the final statement instruction that will execute is the output statement, which is cout min. So here is a complete 3 address code that has been generated via parse tree in the previous demonstration. So this was all from my side about how to translate translation selection statement into a 3 address code. So thanks for watching.